Welcome to my YouTube channel. This is Dave once again, and I'm back with another video presentation employing my homemade Variac device. This is again this silverish black boxy thing, meaning that I will be again testing another AC based appliance or component, something that has a moving part. So this is this motor right here that you see with this two bladed propeller. So this device will be under stress or reviewed in this video presentation. Again, I'll be employing the services of my digital multimeter VoltCraft VC404. Of course, I'll be securing everything, every connection with my screwdriver, and here I have an additional greenish alligator clip for ground. So this is this extension, this black wire over here, because this motor doesn't have an additional grounding wire, so I'll have to improvise in that manner. And another helper in this video presentation will be this massive and heavy vise that I'll be using, because this motor doesn't have any holder that comes with it, so I cannot attach it to something much more sturdy and secure. So I'll be putting this motor into this vise in order to test it, because I cannot exactly hold the motor in my hand while I'm fiddling with 220 volts. That's just not safe, and especially because of these fan blades, you know, something might happen and I might lose an arm, a wrist, and a finger perhaps. So safety first, as always. As usual, I'm going to give you a brief rundown or presentation description of the device that I'll be testing. So this is it. This is the motor. It comes with this actually detachable two-bladed aluminum propeller. This is how it looks like on the back side. These are supposedly MF1536 type of connectors. Something similar you can find, the male end on a 12 volt lead gel battery, for instance. So these connectors would go there, just that these ones are a bit smaller ones. So this is the motor. On the back side, it comes with these two screws, to which you can then attach the motor to some sort of aluminum or plastic case, so metal or plastic. This is of course the winding, copper wire, and this is the information that is on the motor. Here it's missing a little bit, so 220 volts, 50 hertz. This is the manufacturer, the model. Other than that, you know, it's pretty much nicely preserved. And so the shaft is about almost 5 millimeters thick, 4.5 millimeters, and you can actually remove this propeller, and you can do this of course by using my screwdriver and turning this part here clockwise. Maybe I can show you a little bit. So you put it in here, and you just simply, you can see the shaft turning. So you remove the propeller by going clockwise, and you secure it again counterclockwise. So maybe I'll divide this video presentation into two parts, where I'll be testing the motor without this propeller, but attaching some sort of a indicator on the shaft, so that you'll be able to see at which voltage the motor starts to spin, or maybe I'll just leave it as such. I don't know. So this is it. This motor actually came from one of these things. So what this is your ordinary room heater as such. You can see that inside, and the blades, they look of the same design as such. In my case, the plastic casing was broken and I was unable to glue everything into place and most importantly make it safe for further use, so I just salvaged what was possible, and in this case the motor was salvageable, but the heating element that is also inside here, that wasn't so, nevertheless. All there is to do is connect all of this into place, plug in the variac, and we'll start testing. And probably I'm going to actually remove this propeller but mount some sort of an indicator on the shaft so that I won't have to immediately use this vise in order to do the testing of this motor. So I'm probably going to proceed this way for this part of this video presentation. The variac is plugged in via that input power black cable, and it is inserted into this AC power cord, which is through this cable over here, plugged it into my AC wall socket, while here on this side through this white cable the AC voltage will be generated, of course, naturally by turning this improvised knob or gear clockwise. And I have also made secured every connection in this coupling over here, which I will of course zoom in, and the digital multimeter has been set in the correct measuring range. And I have also, as I have mentioned, removed the propeller of this motor or shaft, and I have attached this sort of a sticky piece of paper onto it to give it the indication at which voltage the motor will start to spin. So now I'm just going to move in and zoom in on the connections. This is the up close shot on the actual wiring for the purpose of this first part of the video presentation. So one end of the alligator clip has been clipped or connected onto the actual metal case of the motor, while the other part or the other side has been connected onto this black wire which is sticking out of this coupling, and on the other side is the standardized green yellow wire which indicates grounding, so this connection is securely established. While on the other side here, where the actual AC voltage will be generated or will come through, I have connected or inserted these two wires, which are then connected onto the connector of this motor, or the wires on thereof. So this is where the actual AC voltage will flow through, and I have inserted my test probe leads into the designated slots of this coupling as well. And of course here polarity doesn't matter, so I could put the red test probe lead into the slot where the brown wire goes and vice versa, so here it doesn't matter. This is just again the up close shot on the digital multimeter, so it has been set in the 750 volt AC measuring range because we'll be going beyond 200 volts. So this is how it's supposed to be set up, so that we won't burn out anything or destroy the multimeter in the process of this testing. So this is how it's supposed to be connected or everything set. As usual, we're going to start with something low as a 50 volt AC increment, and then we're going to move up by the same number. So first we start with 50 volts AC to see whether this is the lowest voltage when the motor might start to spin. So nothing on the axis. So even if we apply some visual assistance, nothing happens. So let's go up again, 50 volts. We have some movement. All right. So the motor starts to spin at around 100 volts AC. Let's see if we can go just a notch down. Let's go to 90. No, at 90 it won't spin. So probably around 95, if we apply some help, it starts to turn. So 95 volts is the number when the motor starts to spin if we apply some aid to it through the shaft, and of course the motor in this condition is under no load, so the number would be different if it was attached to like a system of pulleys, or if it would have had the propeller mounted onto it. So 95 volts, so we'll go to 150 volts. You can also hear this paper making a noise. So 150 volts and the motor works nicely. You can also feel a little bit of breeze coming from it. So we'll go again to 50 volts up to 100 volts. So 200 volts and the motor works nicely. I don't know, maybe you can hear it, but I definitely can. That high voltage hum is also present. But maybe that is coming from the variac and not the motor. So let's go to the rated voltage setting, 220. So this is it, 220 volts, and the motor works flawlessly. You can also feel the breeze a little bit. So now this is the end for this part of the presentation. So in the next part I'll be leaving all this connection as it is, and I'll be putting this motor into the vise and reattaching the silver or the aluminum propeller, and we'll repeat the procedure. Now the motor has been inserted into this massive, really massive and large vise, and it has been appropriately secured so nothing will fly off. And I have also positioned the motor in this direction, so if the propeller for some reason might come loose, it won't, hit the angle or in the direction of where I'm facing or the camera. So if it will come off, it will probably go towards the wall or into the variac. But that is just my prediction. You never know how things might turn up in the end. But nevertheless, this is the idea. So I will again, show you behind the wiring. Of course, nothing has changed, but because this vise is blocking the view, you can't see that. So I'll zoom in on that, then we'll start playing. Again, this is how the wiring looks like. I basically didn't change anything. I just filled around with the wires, moved them a little bit. So I moved these two wires, I bended them a little bit downwards, so when the propeller will start to turn and reach full speed, so it won't in the process sever these two wires and create a short and blow up the fuse of my variac. Well, this is the idea. How everything will turn out, of course, is another question. So this is how it looks like. Here I have, again, made the ground connection. So now we'll just start playing. I have repositioned the camera a little bit so that you have a much better overview on the entire experiment or test for this motor. Not to mention this nice massive vise, which is of course hiding the connections on the other side, but you have seen these a little moment ago. So now we'll start as usual 50 volts AC and we'll see if anything happens. I have also moved or repositioned myself on the right side of your screen because this is easier for me. So 50 volts, again nothing. So a little rotational kinetic energy to the shaft. Once again nothing. So we'll go again 50 volts up. Oh, look. So the motor for a moment started to spin, then it stopped. So 90 volts AC and it starts to spin without any assistance naturally. So this is nice movement of the shaft of the rotor, because previously the motor started to spin at 95 volts AC and the mass on the shaft was basically nothing, so this is much heavier, but it starts to spin. So nice. Let's go 50 volts to up again, so 150. So here we are at 150 volts. You can also hear the motor a little bit, becoming more louder. Let's see if it heats up a little bit. No, it's actually cool, but of course this vise also works as a sort of a heat sink because you have metal touching metal, so if the motor was heating up, this would cool it down nicely. But it supposedly it shouldn't be heating up because primarily, like I said, this motor came from a broken room heater and it is mounted onto a plastic holder as such, so it's not supposed to heat up because that would be environmentally hazardous. So 200 volts, let's go. So the motor is becoming louder and also spinning much more faster. But still functional, working. The propeller is still safely secured onto the shaft, so that's also good. Nothing flew away. So last stop, 220 volts AC, which is the nominal rated voltage. Come on. Okay, we're 1 volt above the nominal rated voltage, but still the motor can perform perfectly, even if it is a little bit overclocked, if you want to say. It's also, again, a bit louder. The airflow is probably wonderful, but I won't put my hand on top of that. I don't want to lose it. I'm very attached to my hand, not only physically. So this is the end of this video presentation on this motor. And the next video I'll probably be testing the same kind of motor, but the blades or the propeller will be in black color. But basically it will be the same motor. So from the same room heater, of course different brand I think, can't really remember, but the same appliance as such overall speaking. If you like this presentation or if you learned something new, leave your comment in the comment section below. Be civil, civic, respectful, no profanity, even though I don't know how you can even swear in this type of video presentation or make comments on that, but I won't go into that. So, like, share, and subscribe. This is David. Goodbye.